Good morning. Good morning. Huh? I think everybody is fine. Miladun Nabi Shubhakankshalu for my student who are staying here. Okay. Now I'm going to give that today. I'll give the difference between yesterday psi square. Psi square mean probability of electron density, maximum probability of finding electron density. Okay, finding electron density in a particular direction. Next, we have 4 pi r square psi square dr. This is called radial distribution, and then radial distribution function. What is that meaning? What is that meaning? Have you listened this one word or not? Radial probability function. Radial probability function. Generally, you have used the total cinema, this one only. Yes or no? This is what is the meaning. Maximum finding probability. Okay. Maximum finding probability. Okay. Yes. Past 2 days, previous notes also today I will send to you. Okay. Possibility of a electron, irrespective of the direction. Irrespective of direction. Maximum probability of electron irrespective of direction within a spherical shell thickness of dr from a distance or from the nucleus. Understood, everybody? Or from the nucleus. That is the difference between psi square versus 4 pi r square psi square dr. I think nobody understood. Maximum probability of electron density, maximum probability of finding electron, maximum probability of finding electron in a particular direction is called psi square. What is 4 pi r square psi square dr? That is called generally radial probability function, or d we are showing. Okay, that is maximum probability finding of electron irrespective of the direction within a spherical shell thickness of dr from a distance or from the nucleus. I will show you. For example, here is the nucleus. Yes, it is the distance r irrespective of the direction, he said. And what is the meaning? Irrespective of the direction mean in spherical shell I am taking. It is the distance r from the nucleus. Now, spherical shell thickness of dr. I'm sorry. Okay. Why do I selected spherical shell? Because irrespective of the direction means all directions whose thickness is dr. Okay, that means in this this is the distance r from the nucleus in this spherical shell thickness, in this thickness. What is the electron density? That is called as 4 pi r square psi square dr. Sir, why do you wrote 4 pi square dr square? Yes, why do I wrote that one? Okay, sir, why do you write this only for this thickness probability? Yes, I will prove that also. Sir, volume of the sphere, volume of solid sphere, volume of solid sphere is how much? 4 by 3 pi r cube. What is the volume of a dotted sphere? Dotted sphere 4 by 3 pi r plus dr. Yes or more, darlings? Understood my point? 4 pi 4 by 3. Now volume of spherical shell thickness. Spherical shell of thickness dr is volume of spherical shell of thickness dr is, and in this volume only I am calculating, and that arrow mark volume only. How much? This minus this one, and I have 2, this is 1, that is 2 minus 1 you do, that is the volume you will get. This is the total thickness, this is the only this the volume. So now I want to get only this volume only, so I am removing 2 minus 1, that is equal to 4 by 3 pi into r cube plus dr cube. Yes or no? 4 by 3 pi r cube, a cube plus b cube plus 3a square b, 3r square dr plus 3b square a, and 3 dr square r. Is it right? Minus 4 by 3 pi r cube. Now this 4 by 3 pi r cube, this 4 by 3 pi r cube cancel. Yes or no? You see, darling, r is a bigger one, dr is a very less. Dr cube and dr square, these are also very less. That is why I can't consider. Now you multiply 4 by 3 inside, 4 by 3 pi into 3 r square dr. Now 3 gets cancelled, and the remaining value which you left is 4 pi r square dr. This is the 4 pi r square dr. What is this? Thickness of this, and this volume of only for this thickness volume. Now you got volume. What is the density in this volume? Electron density in the spherical shell thickness. Spherical shell thickness of dr is their volume into probability. Volume is how much? 4 pi r square dr into probability of electron psi square. That is equal to 4 pi r square psi square dr. Yes, that is the reason why you are writing this value. Anybody having the doubt, you can ask me. Yes, students. Yes, that is the reason why you are writing 4 pi r square psi square dr, radial probability function. So radial probability function, why do you write this value? Because we are calculating, this meaning is that it is not at nucleus. This is the electron density at a distance r from the nucleus. This is the point everybody should remember in mind. That is not at nucleus. Not at nucleus. And this meaning is not at nucleus, at a distance r from the nucleus. This is called electron density. Got my point, everybody? Now I will give the clarity for you. Yesterday and today. Yes, how to remember. Some students are seeing till now, they are sending the WhatsApp doubts on this. I will clarify your doubts now. Psi versus r. Psi square versus r. Now d versus r. D means 4 pi r square psi square dr. Now you see, I am writing only for 1s orbital. Here also 1s orbital. Here also 1s orbital. For 1s orbital, near the nucleus, electron density symmetric, spherically symmetric. S orbitals are spherically symmetric, and always electron density is coming towards the nucleus. That means near to the nucleus, electron density is very high. That is why for s orbital always you are starting from here. For psi square also, yes. I'm sorry. It comes up to here like this. But sir, why do you wrote like this? Why? D means it is a distance r from the nucleus. Not we are calculating this value at nucleus. At a distance r from the nucleus for s orbital also, electron density 0. Yes. That is the difference. Psi versus R, psi square versus R, D versus R for 1s orbital. Okay. For the same thing, students. Psi versus R, psi square versus R, 4 pi R square psi square versus dr versus R. For 2s orbital, I am drawing. For 2s orbital. So, you carefully observe. 2s orbital. For every s orbital, electron density near to the nucleus, very high. One node is occurred. Yes, one node was occurred. Next, for psi square, what is the difference? Yes, this is the difference. Why? Always it is positive, this positive and negative. What about this, sir? Yes, like this. And a one node. Got my point? Sir, why do you start from here? Why do you start from here? Psi and psi square, they are calculating near nucleus. That 4 pi r square psi square dr. This is radial probability function. It is at a distance r from the nucleus. So at nucleus I am not calculating. At a distance r onwards I am starting. That is why they are starting from here. This is 1s is equal to 2p. 2p is equal to 3d, which is equal to 4f. For like this. This is for 3p or 4d or 5f. Yes, once in IIT examination they given like this. 4 pi r square psi square dr. Eppudo kaadu 2017 or 18 what is that? The IIT exam, advanced exam. They given like this. The graph represents A 4p, B 3s, C 6f, D 5d. Which is correct? Yes, 4 pi r square psi square dr. All of them is correct. Why, sir? Nodes how many you see? Nodes. One node, two nodes. That is for this one, n minus l minus 1, 4 minus 1 minus 1, 2 nodes. For this, 3 minus 0 minus 1, 2 nodes. For this, 6 minus 3 minus 1, 2 nodes. For this, 5 minus 2 minus 1, 2 nodes. Therefore, this is the correct answer. Understood? This is the way you will get some graphical type of questions in your examination. And number 2, I will give you that nodes. What is a node? Where the electron probability is 0, they call node. There are 2 types of nodes are there. They are node. Node is nothing but electron density is equal to 0. That means where electron is not present is called 0 other than nucleus. Other than nucleus. Okay. That is radial nodes. Radial node. Okay na? And next angular nodes. Okay. Radial node or angular node. Radial nodes are also called spherical node. Spherical node. These are also called non-spherical nodes. These are also called nodal regions. These are also called nodal planes. You please see the names. You please observe the name. Radial nodes are calculated by, what is the formula? N minus L minus 1. Angular nodes are calculated by L. Okay, so n minus L minus 1 indicates nodal region or spherical nodes. Sir, for example, nodal planes. Nodal planes is equal to angular nodes. Nodal planes is equal to angular nodes. So for L is equal to 2. L equal to 2 means d orbital. So for d orbital, how many nodal planes are there? Therefore, nodal planes should be 2 for except dz square, except dz square. Dz square as 0 nodal plane, but has 2 nodal cones or regions. Nodal cones are nodal regions. Please underline, your honor. This is the very important point. Yes, Those students who are having the doubts, please clarify yourself here, because they won't teach again and again in your throughout intermediates. It's my open challenge. This is true. Absolutely true. Once again, anybody required, take the clarity yourself. Have you know this point? My question. Anybody in the classroom who are listening my class? I'm asking you that. Huh? What is that? Sir, why do you call radial nodes as a spherical node? My question. Anybody in the classroom who are listening my class, I'm asking you that. Why do you call radial node as a spherical node? Radial node as a spherical node. My question. Can you explain that? Have you proved your lecture in previously? Why do you call radial node as spherical node? Okay. For your convenience, I will prove. Okay. For your convenience, I will prove. See that. R of R 2s is equal to 1 by 2 root 2 into 1 by a naught whole power 3 by 2 into 2 minus what is that, 2r by what is that, 2a naught 2r by 2a naught, okay na, into e power sigma by 2, where otherwise for your convenience, okay, for your convenience I will write a sigma is equal to 2r by 2a naught, na naught actually, 2r by na naught, okay na. So students, I will prove why that nodal radial nodes are called spherical nodes. If you want, sir, how do you identify, how can you identify this as a, what is the 2s orbital? Yes, I can identify this as a 2s orbital. How, sir? That is, wait ma, here r power anything is there? Nothing is there. R power 0 means r power 0, that is equal to s orbital, so it is must be s orbital. Number 2, e power za by na naught, I given n is equal to 2. If I given n is equal to 2, that is why it is a 2s orbital. Okay, you put aside, I am not requiring that. Sir, radial node, what is meant by radial node? Where the probability of electron density becomes 0. What is meant by radial node? Where psi is equal to 0. Okay, so psi equal to 0. If psi is equal to 0, where the psi equal to 0, that is called radial node. Sir, to become psi equal to 0 means it is constant. It cannot be 0. It is constant, cannot be 0. E power cannot be 0. So who will become 0? Yes, 2 minus 2r by 2a naught is equal to 0. That is 2 is equal to 2r by 2a naught is equal to 0. Then r is equal to 2a naught. Therefore, for s orbital, for which orbital? 2s orbital at a distance of 2a naught. Sir, what is a naught? Bohr's atomic radius. That is equal to 0.529 angstroms. Yes. So at a distance of 2a naught, okay, for 2s orbital, radial node occur. You understood my point? Sir, why? Distance mean radial node. Do you know the meaning of distance? Distance dependent node is called radial. Direction dependent is called angular node. Okay now? So now you come to the point. All of you come to the point. So this is the nucleus. This is the nucleus. For 1s orbital, the distance is, yes, r. Now what is said? This is a naught. This is a naught. Now at a distance, one more a naught. You see that, students. All of you see the students. This is A naught plus A naught. This total become 2A naught. Just now I said at 2A naught electron density 0. So this is 2A naught. Oh, sorry. So at a distance of this 2A naught, electron density 0. Yes. At a distance of 2A naught, electron density 0. Yes. At a distance of 2A naught. This is A naught, Nana. This is A naught, 2A naught. And at a distance of 2A naught from the nucleus, electron density 0. Just mathematically I proved. Now I am connecting all these points. Do you have any problem? What it become? After connecting, it become a spherical shell. Spheric. Therefore, the radial node shall I call as a spherical node. It is the proof. Is it correct or not? So the radial nodes become, what is that? Spherical node. That is the reason why I called radial nodes as a spherical node. At a distance of 2A naught from the around the nucleus, the electron density is 0. Before that and after that, electron density is present. At exactly at this point, electron density is 0. That is called radial node. Therefore, if I connect all these points, I got the spheric. Therefore, these radial nodes are also called spherical nodes. This is the proof I think you should get in your first year. Okay? Okay. For your convenience, I'll give you some more knowledge. Okay? I have doubt. Some students are asking. Okay, students, I'm sorry. Wait. How do you set n equal to 2? Okay, darling. Okay, okay. For your convenience, psi is equal to root 2 by 81 root pi a naught power 3 by 2 into 6 minus r by a naught whole into r by a naught into e power minus r by 3a naught into sin theta cos pi I got. Now student ask me now doubt. Which orbital it represents? How many of you in the class? The given one, which orbital it represents? Which one this represent which orbital? My question. Yes. Now, if you know, automatically you can understand the point. Tell me. My question. How can you get? Okay. Some student has just now asked me, sir, how you said that n equal to 2? No, radial nodes only. Okay, make it fast. How many of you, anybody in the class who are listening? Can you answer that? Yes. Sai Vignesh. What is the answer? Akash Kumar.
Sir, PX, sir.
PX only?
Yes, sir.
Which PX?
Sir, that sir, and I don't know.
Yes, that is the point I want to say to you. Psi is equal to, okay now, R power L into K means constant, R power L into r power of n minus L minus 1 function, okay na, into e power minus ZR by NA naught. Compare every time like this. Here k is nothing but this is the constant. Here r power L. R power is how much here? You see, r power is how much here? 1 is there. Therefore, L is equal to 1. I got the point. Second point, r power n minus L minus 1. What is the function here? 1 is there. Therefore, n minus L minus 1 is equal to 1. Already L equal to 1. So, n minus 1 equal to 1. I'm sorry. Okay, is equal to 1. Therefore, n is equal to 3. So, I got n equal to 3. I got L equal to 1. Therefore, n equal to 3 mean 3. L equal to 1 mean p orbital. And next, I will give you one more logic also. Here, you compare n is equal to what? N is equal to what? 3. In that way also you can know n equal to 3, n equal to 3. Okay, here e power minus ZR by NA naught. E power minus ZR by NA naught. N is equal to 3. Yes, I can get n equal like that also. Number 2. Sir, here sin theta cos pi. The sin theta cos pi component indicates x. Therefore, the given orbital is a 3px orbital. Understood? This is the very important point. That means while looking at this type of questions, every student are just omitting the class. Yes or no? But it is easy to understand. Now you got the point or not? How easy? By component, you know the direction. By this one, you know the n value. By this one, you know the n minus L minus value. From this one, you know the L value. Sir, in this equation, you see? In this equation, R was not given. R was not given mean R power 0. And L is equal to 0. And S orbital. Yes, you see S orbital? Yes. Ante you know the psi function. By looking at the psi function, now you are able to answer the function which is the orbital belongs to. I think.
Sir,
Okay.
if phi is equal to 0, sir, so then it will be angular node, na?
Tell me.
Sir, if phi is equal to 0, then it will be angular node.
Psi is equal to 0.
Phi, sir.
Phi is equal to 0.
Yes, sir. Sir, but in a previous question you have written it is a radial node.
Where?
Sir, above this page.
Okay, tell me.
Sir, here radial node is phi is equal to 0.
Psi is equal to 0, not phi. Phi ante idi.
Okay, sir. I misunderstood. And
Psi
sir,
is
what
equal
is
to
the
0.
difference? Sir, and what is the difference between electron density and pi r square xi square dr?
Psi square
And
4 pi r square psi square dr. This is the difference you want?
sir, and electron density also.
That is only. All these are indicating electron density only. All these meanings are indicating electron density.
Sir, but psi will not represent electron density.
No, psi is also a electron density. Psi is nothing but electron wave function. Is it right?
Yes, sir.
And what is the meaning? Electron only. Psi represent electron. Psi represent electron wave function. That may be positive and negative. To get always positive value, you are taking what is that psi square.
Okay, sir. Sir,
Psi
means
may be positive and negative, but psi square is always
positive.
But this will give always electron density in one direction only.
Yes, sir. And 4 pi r square
This
xi.
indicates all the direction, irrespective of the direction, electron probability at a distance r from the any nucleus, at a distance r from the nucleus.
Okay, sir. Thank you, sir. I
Understood
understood.
the difference now?
Yes, sir.
Thank you.
Welcome, sir.
Now I am very happy. Now, okay, these are the things you have completed. Some student yesterday asked me, I think those who sent the doubts, I think it is cleared. Now, I think I don't know who is the student, 939832162. Okay, you send one question. Electron party, what is a particularly at rest? It is initially accelerated through a potential difference of 100 volts. Yes, that is correct only. What you done? Lambda is equal to h by square root of 2 MEV. HUMEV, E constant. Who is changing? V only. Then lambda 3 minus some student Nana, I don't know his name. Lambda 3 minus lambda 2 by lambda 1 you asked me. H root 2 by ME, everyone is cancelled. then answer will be 1 by root 32 minus 1 by root 19 by 1 by root 100. You will get, you do this answer, you will get the answer. What you done is correct, Mr. Who was sent to me last mobile number 1632. Okay na? Now I am going for periodic table. Okay na? In periodic table I want to ask some questions. Shall I ask? Okay. Okay, student. Atomic number 63, atomic number 42, atomic number 36, atomic number 54 belongs to which group? Which group? My question, please make it fast. Okay. How many of the student have completed answer? Wow. 128 student to 126 again come back. It's not good. Banu Teja.
Sir, 63 is third B block, sir.
Excellent. Without doing anything, you have to say very good. Why? 58 to 71. 58 to 71. They belongs to third B group R4F series. Understood, mister? And next, other student.
42 is 6th. 42 is 6th B.
How could you say that directly?
Sir, as it is 43, it's the nearest noble gas is 36.
Yes, I have given this one. Group number is equal to, what is that? Z of, I said like this only, na? 1832 minus 18 minus. Is it right?
Yes, sir.
18 minus, what I given? I forgot. I'm sorry. అప్పుడే అయిపోయింది క్లాసు, డ్రాప్ అయిపోతున్నారు ఎందుకురా భయ్? I won't like this. Okay. If you drop, I will also drop. Don't worry. నాకెందుకు రా నెసిటీ ఏంటి? నాకు ఆరామ్సే ఏదో ఒకటి పెట్టేసి చేసుకోండి అంటే సరిపోదా నాకు? మీకు ఇష్టమేం చేసుకొని అట్లా కూర్చుంటా అంటే ఓకేనా? వాట్ ఈస్ ద నీడ్ ఆఫ్ టు మీ? 18 minus Z of inert gas, nearest inert gas, minus Z of, what is that, Nana? Given. That is 18 minus just next inert gas is 54 xenon minus Z given is 42. Then you will get 8 plus 14, 12. 8 minus 14, that is 6. That is equal to 8 minus 12 is 6. That is equal to 6th group. Yes or no? That belongs to 6th group. Got my point? Like this, you can get the answers. Try it for that.
Sir, 36 and 54 belongs to noble gas.
54 is a noble gas. That is 18th group, na?
Yes, sir. Even 36 also
noble
gas, sir.
Yes, that is only. Easily you can get the answer. Next, I'll give one more question for you. Okay. Okay, next question. If each orbital has spin -1, 0, +1. Okay, each orbital has spin -1, 0, +1. Then maximum number of electron in what is that, ninth period. Ninth period is how many? Anybody in the class? Yes, Akash Kumar, good boy.
So 75.
75.
5.
Very good. Very good. You did good job. Why? Each orbital has a spin -1, 0, +1. And each orbital accommodate 3 electron. If 3 electron, how many will be there? If 2 electron, how many? If you know, automatically 3 electron, how many will be known? If 3 electron is 2 electron present. If 2 electron present. Okay. Number of elements. Number of electron is wrong. Number of elements. Number of elements is equal to n plus 1 whole square by 2. Sir, why do you write n plus 1 whole square? N is period number. 9 plus 1 whole square by 2, that is 100. 50 elements are there. If 2 electron present, number of element is 50. If 3 electron is present, number of elements are 50 into 3 by 2, that is equal to 75. Sir, why do you wrote this formula? This formula is useful when odd number of period is given. If even period is there, n by plus 2 whole square by 2. Please remember the point. Please remember the point. Okay, darlings. నీకు ఇప్పుడు మీకు ఒక క్వశ్చన్ ఏంటో తెలుసా అది? Yes. You see? Oh, shit. Okay. Have you seen this one? Okay. First you answer this. Sir, lanthanide contraction. You know what is lanthanide contraction? From cerium, that is 58. You see, that is cerium. This is, what is that? Up to lutetium, 71. Cerium to lutetium, there is a regular decrease in size. That is called as lanthanide contraction. But have you observed, this is the Narayana material. Okay, కాన్సెప్ట్ లో నుంచి తీసుకున్నానండి. హ్యావ్ యూ సీన్ దట్? హ్యావ్ యూ ఆస్క్డ్ యువర్ లెక్చరర్? యురేపియం అండ్ yttrium abnormally have higher, what is that, atomic size, highest atomic size in 4f series urapium, and my yttrium also greater than lutetium. Why? That is my question. That is the original answer for your convenience. Okay, what is that answer? Cerium greater than promethium, niobium, plasmodium, samarium, urapium. Okay, generally you are expecting, but you see, this is greater than urapium. Absolutely. Gadolinium, terbium, dermastridium, holmium, iridium, thallium, and yttrium is greater than lutetium. Please see that. 1 minute, Nana. Wait for 1 minute. I'm sorry. Somebody are calling. Madam, చెప్పండి. హలో. వెయిట్ మా వస్తున్నా, ఉండండి ఒక్క నిమిషం. ఓకే స్టూడెంట్స్, ప్లీజ్ వెయిట్ ఇన్ 5 minutes, 2 minutes. Actually, one student is going to London. That's why he came to get my sign. That is the reason. Okay. Okay. You see here, observe the logic. Here, abnormally it is more and abnormally it is more. What is the reason? This is the IIT question they are asking. Yes. They are asking in IIT like this. Huh? If you observe the same thing in your Narayana material, have you seen or not? I don't know. In your Narayana material, there is a one more thing. I think you didn't see this. Same at non-thyroid contraction itself. Have you seen this too? In your Narayana material? If you observe that, this in metallic radius, if you consider, this is only metallic radius or atomic radius. You see, this is atomic radius. If we consider the atomic radius, a student, if we consider the atomic radius, okay, uranium is highest. If we consider the ionic radius, you don't consider this, and cerium is highest. Observe the logic. Uranium become as usual only. Tritium become as usual only. If we consider ionic radius and atomic radius, that is why they will ask in IIT examination this question. In atomic radius, uranium is highest, but ionic radius, uranium is not. Cerium only highest. Top to bottom as usual decrease. Why? The reason here 4F7, 5D, sorry, 6D. Generally, what is the configuration? 4F 1 to 14, 5D 1, 4F 1 to 14, 5D 1, 6S2. This is the general outermost configuration for 4F series elements. If you take this uranium, instead of 6D0, sorry, 5D0 and 6S2 is appear. For yttrium also, 4F14, 5D0, 6S2 is present. Because of half-filled, fully filled, they participated 2 electrons in metallic bond. This also participated 2 electrons in metallic bond. But remaining element participates by 3 electrons. 3 electron in metallic bond. Sir, if they participated 3 electron in metallic bond, if they participated 2 electron in metallic bond, radius changes? Absolutely radius changes, sir. Why it is, sir? If the 3 electron participate, the bond is strong. Automatically the atoms come closer. If they come closer, the length is the radius decreases. If they participated 2 electron in metallic bonding, as that metallic bond depends upon number of electrons. Metallic bond strength depends upon number of electrons. As the number of electrons are participated more, strength is more. Strength is more, atoms are closer. Atoms are closer, their distance is less. If the strength is less, number of electron less, strength is less. Atoms are far away. That is why radius is far away. Yes, the radius calculated based on the bonding. If the bonding is loose bonding, more larger radius. Is the strong bonding, that is the reason why they have less radius. That is why that is the abnormality. I think this is the point they are asking in IIT examination. Sir, what about European 3? European 3 means European plus 3, the 3 electron. All of them are participating 3 electron in ionic radius. M plus 3, all are removing 3 electron. That is why no abnormal change. That is why these two tables are given in your Narayana material. Have you observed this one? Absolutely. Yes, students. I think no student have observed this logic. Okay. These are the questions they are asking in IIT examinations. Okay, na? At the end of the class, all of you are going to be drawn. So this is the very, very important clue for the periodic table regarding that at ionic radius and atomic radius of lanthanide contraction. Lanthanide contraction means cerium to lutetium, a regular gradation of decrease. Yes. But at europium, but ytterbium, atomic radius is abnormal. But ionic radius, as usual. Please underline, your honor. That is a very important point. Okay. Tomorrow we will discuss some more points regarding to your lesson. Okay. I want to stop. I will send the notes 100%.